AP Calculus BC, Unit 5, Day 15, Office Hours Pretest says to get ready for the upcoming test. Probably going to split this video into two parts and do the relay rate separate, depending on how time goes. So, let's see. Just trying to get everything situated nicely first. So, lots of new integration techniques as well as some old ones. So, keep in mind sometimes it's easier than you're trying to make it. I like to rewrite these as cosine 2x cube sine 2x. So I would say just regular U-Substitution, cosine 2x looks like it might work. D equals negative 2 sine 2x. Don't forget the chain rule. Dx. I don't want the negative 2. So if I rewrite this, it's going to be negative 1/2 u cubed du. It's going to be negative 1/2 u to the 4th over 4 plus c equals negative 1/8, and write it back in terms of the original variable. Now, usually we would kind of write it back in that sort of lazy format. Negative 1/8 cosine, put the 4th power there. I mean, that's the way you're always going to see it. All right. Number 2. Probably just regular old U-Substitution. Looks like it's going to work. You can usually kind of check in your head. And I thought, what, that looks good. X cubed dx, I want the 4. So that's going to be 1/4 du over u, which is going to be 1/4 natural log of the absolute value of u plus c, which is going to be 1/4 natural log of the absolute value of x to the 4th plus 7 plus c. And final answer should not have the absolute values anymore because they're unnecessary. So still need some kind of grouping symbols to show that everything's inside the natural log. There you go. Okay, number 3. U-Substitution is not going to work. Not the normal just denominator, right? If you did u equals x to the 4th plus 4 du equals 4x cubed dx, that's not going to work because we need x dx. Which makes you think, well, maybe this is like inverse tangent. But you got to make that a 1 first. So we're going to need to factor 1/4 out of everything in the bottom. And then that would be your u, x squared over 2. U equals x squared over 2. Du equals x dx. So this is going to be 1/4. 1/4 du over u squared plus 1. So that's going to be 1/4 inverse tangent u plus c. So that's going to be 1/4 inverse tangent of u, which is x squared over 2 plus c. So far nothing new from this year. Number 4, I think just regular U-Substitution. D equals negative 4, x cubed dx, that looks like it's going to work. We divide by negative 4, both sides. Okay, so we're at negative 1/4 in front. Let's going to be du over the square root of u, which should be -1/4 u to the -1/2 du. It's going to be -1/4 u to the 1/2, bump it up 1, divide by the new exponent, plus c. It's going to be -1/2 square root of 1 minus x to the 4th plus c. Okay, number 5. U equals natural log x. I think it's going to work. Du equals 1 over x dx. That's good. So it's going to be du over u. So it's going to be natural log of the absolute value of u plus c. So it's going to be natural log of the absolute value of the natural log of x plus c. And we have to keep those absolute values because natural log can be negative. There are no absolute values on the inside, though. Okay, number 6. U-Substitution is not going to work. Can't do partial fractions because the degree of the top is the same as the bottom, so you have to do long division when the degree of the top is bigger or equal to the bottom. We try that. So x squared plus 0x plus 6, x squared plus 0x plus 1. It's good to put the missing places there. Divide the first ones, that's 1. Distribute. Subtract. That's the remainder. As soon as this is less than that, then you're done. So we're going to rewrite it. And it's going to be 1 plus 5 over the denominator. So then that's going to be x plus, this is going to be inverse tangent plus c. So that is one of our new techniques. Number 7, I don't think U-Substitution is going to work here. So, and because the degree of the top is bigger than the bottom, we got to start with long division. So that's going to be x to the 4th plus 0x cubed plus 2x squared plus 0x minus 5 divided by x squared plus 0x plus 4. So that's going to be x squared. And distribute that. X to the 4th. First term should always cancel out if you've done that right. Plus 0x cubed plus 4x squared. Subtract. I think we probably drop all these down and match these up. So it's going to be negative 2x squared divided by x squared is going to be minus 2. Minus 2x squared plus 0x minus 8. Subtract. It's going to be 3 is the remainder. Okay, so now we're going to rewrite this as x squared minus 2 plus 3 over the denominator. And these are going to be easy to integrate. This, we need a factor of 4 out to make that a 1, because this is going to be tangent. It's going to be x over 2 squared. So it's going to be u equals x over 2, du equals 1/2 dx. I don't want the 1/2. So this is going to be x cubed over 3 minus 2x on their own plus 1/4. Another 2 pops out. Integral of, there's a 3 on the inside. I guess I could move that out. It's going to be u squared plus 1 du. Bring the 3 out. Inverse tangent of u. So I still need to change it back to the original variables. So it's going to be, we can say 1/3 x cubed minus 2x plus 3/2 inverse tan of x over 2 plus c. There you go. Okay. Okay, next page. So partial fractions, these first two are just the algebra steps of it, no calculus. So, and they're kind of done for you. X plus 3, x minus 2. So multiply 3 by the least common denominator. You can get rid of either one first. So it's going to be negative 5a equals negative 20. So a equals 4. And we can plug 2 in. And we get 5b equals 15. So b equals 3. Next one is a special case, x minus 2, x minus 2. So this is a double repeated root. So you do one with just to the first power, and then you do one with the second power. Multiply 3 by the least common denominator. You're going to get a x minus 2 plus b equals 5x minus 7. So you run into an issue where you can't get rid of b, which is fine. So get rid of a first, and you get b equals 3. But then we're going to plug 3 in here, and then plug in anything we wanted for x so that a doesn't go away. I pick 3 just to make it a 1a. So then a plus 3 equals 15 minus 7 is 8. So a equals 5. So that's how you deal with that repeated situation. Now let's bring it into some integrals. So x plus 5, x minus 3. So it's going to be a over x plus 5 plus b over x minus 3. Multiply 3 by the least common denominator. Get rid of either one this time. So it's going to be negative 28 equals negative 8a. Let's see, is there something wrong here? Oh, I messed up here. That should be a 2. So it's going to be negative 7a. Not that the answers can't come out kind of weird sometimes, but lots of times they come out nice. So we plug 2's in here. It's going to be negative 21 equals 7b. So b equals negative 3. So equals, I'm going to rewrite this, 4 dx over x plus 5 minus 3 dx over x minus 2 equals 4 natural log of the absolute value of x plus 5 minus 3 natural log of the absolute value of x minus 2 plus c. And then I do want you to combine these together with the log rule. So this means natural log of x plus 5 to the 4th. We can drop the absolute values because now it's raised to an even power over x minus 2 to the 3rd. Need the absolute values there still. That's all inside of it, plus c. Okay, all right. Number 11. Let's see, x squared plus 1. No long division. We could try partial fractions. Let's see what happens. So a over x plus b over x squared plus 1 dx. Multiply 3 by the least common denominator. 5x squared plus 3x plus 5 equals a. x squared plus 1 plus bx. Make the x go away by plugging zeros in everywhere. You get 5 equals a. Can't make the a go away though. Well, kind of adopt strategy like we did for the repeated roots. Let's plug 5a in. Let's plug 5 in for a. And then plug whatever you want in for x. And then plug a 1. So that's going to be 5 plus 3 plus 5 is 13 equals 10 plus b. So b equals 3. So sometimes you can't just make it go away. So we're going to rewrite this, and it's going to be 5 times dx over x plus 3 times dx over x squared plus 1. So it's going to be 5 natural log the absolute value of x plus 3 inverse tangent of x plus c. Okay. Number 12, right away, I noticed they have the same degree, so don't start doing partial fractions. So you might seem to get far and get an answer that even looks close to the right answer, but it's not going to be right. Something's going to be a little off, and you'll have wasted a lot of energy. So we got to start with long division. So 2x squared plus 19x plus 51, x squared plus 8x plus 16, 2x squared plus 16x plus 32, 3x, 19. So this is the remainder. So this is going to be 3 plus 3x plus 19 over x squared plus 8x plus 16. Now this regular U-Substitution is not going to work, so we're going to need to probably try and do partial fractions. X plus 4, it's repeated root. So it's going to equal a over x plus 4 plus b over x plus 4 squared. Multiply. Now this part's fine on its own. I'm just dealing with this part right here. So it's going to be 3x plus 19 equals a, x plus 4 plus b. Can't get rid of the b, just get rid of the a first. So that's going to be 7 equals b. So we can plug 7 in and then plug whatever you want in for a. I'm going to plug -3 just so it comes out as a nice positive 1a. So that's going to be 10 equals a plus 7. So a equals 3. So we're going to rewrite it now. Kind of running out of room. You right over here. This is the integral. We have the 3 still. And then, I mean, I guess we could just break that up. 3 dx plus 3 dx over x plus 4 plus 7 dx over x plus 4 squared. All right, so it's going to be 3x plus 3 natural log of the absolute value of x plus 4. This is a power rule. So it's going to be plus x plus 4, bump it up 1, divide by the new exponent plus c. Final answer, 3x plus 3 natural log of the absolute value of x plus 4 minus 1 over x plus 4 plus c. That was kind of crazy. Now in my answer, I'm checking right now, it says 7. Did I mess something up? Oh, there was a 7 just hanging out here, right? Yeah. So this should be 7. Okay, there we go. All right. Okay, integration by parts, Lipit. The formula, it's uv prime, and it equals uv minus the integral of the 2 new parts. I don't even try to memorize this formula, but so you got to figure out what u and what v prime is. And then it's going to be u prime v, because whatever you get from these, so you have to take derivative of u, get u prime, integrate v prime, and get v. So that's integration by parts. Lipit is helps you with order. So this is polynomial, this is exponential. If you need to write that out, the first time, log inverse trig polynomial exponential and regular trig. Okay, so we have poly expo, which qualifies for a shortcut. And this is a good one to do it. Otherwise, you're going to have to do integration by parts repeatedly. So you take the derivative, 2x, keep taking it until you get a 0. And the other side, you exponentiate. And then you start positive, negative, positive, negative, multiply by a diagonal. And so we get let's see, x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Don't forget the plus c. So that's the shortcut. If you do it the long way, I don't think you want to. Okay, this one is poly trig and Lipit. Poly expo, poly trig are the shortcut ones. They're the only ones where you're going to have the polynomial go away, 3x squared, and it could eventually go to 0. And the other one you can actually integrate still. So this is going to be negative 1/2 cosine 2x. And then that's going to be negative 1/4 sine 2x. And that's going to be 1/8 cosine 2x. And then that's going to be 1/16 sine 2x. Positive, negative, positive, negative, positive. Okay. So let's see, what are we going to get? It's kind of a long answer. I guess I'll write it over here. So we can get negative 1/2 x cubed cosine 2x, right, plus 3/4 x squared sine 2x plus 3/4 x cosine 2x minus 3/8 sine 2x plus c. Okay. Keep going. All right, can't integrate this with any other techniques, so we're going to use polylog. Lipit. Polylog. So the first one is going to be your u, and then the other one's got to be v prime. So u equals natural log of x, and v prime equals x dx. So whatever the v prime is gets the dx. Then you're going to take the derivative, you get 1 over x dx. Then you're going to integrate this one, and you're going to get x squared over 2. So then when you rewrite this, it's going to be uv, it's going to be 1/2 x squared natural log of x minus the integral of the two new things, which is going to be 1 over x squared over 2 dx. Now that simplifies to just, x over 2. We can move the 1/2 in front. So it's 1/2 x squared natural log of x minus 1/2. And then you have an x to the first. So you bump it up 1, divide by the new exponent, plus c. So there we go. That worked. Okay, next one. Can we integrate this any other way? I don't think so. We're going to try poly inverse trig. So Lipit Pauli inverse trig. So inverse trig has to be the U, and then the Pauli has to be the V prime. No shortcut. So U equals inverse tangent of x. V prime equals x squared dx. You take derivative. It's going to be 1 over x squared plus 1 dx. And V is going to equal x cubed over 3. So it's going to be UV 1/3 x cubed inverse tangent of x minus the two new things. And I'll move the 1/3 out in front. Now, let's see, how do we integrate that? U-Substitution is not going to work. I guess we got to do like long division, right? X cubed, x squared plus 0x plus 1. This one's tough. All right. So x, distribute that. X cubed plus 0x squared plus 1x. Negative 1x plus 0. So this is your, well, we could go, nope, that's a remainder. Okay, so we have 1/3 x cubed. So now we have x minus 1 over x squared plus 1. All right, we can integrate that. Getting close. Minus 1/3 x squared over 2 plus 1/3 inverse tangent of x plus c. Oh, wait, I messed up. The remainder has an x on the top. So that's not inverse tangent. That's U-Substitution. U equals x squared plus 1. Du equals 2x dx. With the 2. Wow. This one's bad. Okay, so that's going to be, that one's not done yet. You have another 1/2 in front. And then you have du over u inside. So it's going to be natural log the absolute value of u. So it's going to be 1/3 x cubed inverse tangent of x minus 1/6 x squared plus 1/6 natural log of the absolute value of, what was it? X squared plus 1. And then we can write it one more step without the absolute values for the final best answer. Wow, that was a crazy one. That one had so many different twists and turns in it. Double check my answer. Looks good. Okay. All right. Next one, we can't integrate that any other way. So this is Expo, and this is Trig. Flip it. Expo and Trig, no shortcut here. If you tried it, it wouldn't work anyways. It's not like you accidentally did pull it off. So whatever's first is your U, whatever's second is your V prime. So U equals e to the x, V prime equals cosine x dx. So U prime equals e to the x dx, and V equals sine x. So it's going to be UV e to the x sine x minus the two new things, e to the x sine x dx. Oh, you guys recognize what's happening? I think we're about to go in circles, but I also know how I'm going to deal with it. So we're going to do it again. This is Expo Trig. So this is your U, this is your V prime. So this is the second set. U equals e to the x. So then U prime is going to equal e to the x dx. V prime equals sine x dx. So then V equals negative cosine x. So it's going to be e to the x sine x minus parentheses, all whatever comes next has to be subtracted. So it's going to be negative e to the x cosine x minus the integral of the two new things, which has a negative. Clearly, we're going in circles, but got to distribute this afterwards. But look, we finally got the same thing we started with. So we're going to move this to the other side. Now, be careful. Maybe we should get rid of these parentheses first. This is going to end up being minus. So I'm going to add this to both sides. I'm going to add this up here. Right? It cancels out. So then I rewrite this. I get 2 e to the x cosine x dx equals e to the x sine x plus e to the x cosine x plus c. And we could divide everything by 2. And we finally get e to the x cosine x dx equals 1/2 e to the x sine x plus 1/2 e to the x cosine x plus c. Don't write 1/2 c. So that's that kind of special case. That's how we deal with it. And if you look at number 18, you should be like, it's gonna be kind of like that. So we have Expo and Trig. So a little bit Expo and Trig. So this is going to be your U. This is your V prime. Now A is just some number. So that's going to probably end up being your answer, but it's just a constant. So U equals e to the ax. V prime equals sine x dx. So U prime equals a e to the ax dx, and V equals negative cosine x. So we're going to rewrite it. Negative e to the ax cosine x minus the integral of the two new things together. Now the a we could just push out front if you want. And there's another negative, right? So it's going to be e to the ax cosine x dx. So we're going to have to do it again. This is Expo. This is Trig. So this is going to be your u. This is going to be v prime. So we have u equals e to the ax, and v prime equals cosine x dx. And then u prime equals a to the e ax dx, and v equals sine x. So we have negative e to the ax cosine x. Now there is an a here that's going to multiply all of this. So put parentheses, uv e to the ax sine x minus the integral of the two new things. Just going to have another a here, e to the ax sine x dx. Now, here's the deal. We got to match, right? So we're going to move this to the other side. Now, be careful. This a gets distributed. So when we move it to the other side and we want to combine them together, there's going to be 1 plus a squared e to the ax sine x dx. That's what's on the left. On the right is a negative e to the ax cosine x plus a e to the ax sine x plus c. So we're going to divide both sides by 1 plus a squared. And so our final answer is e to the ax sine x dx equals, and we could just leave it all divided. We could just say negative e to the ax cosine x plus a e to the ax sine x divided by a squared plus 1 plus c afterwards. So those are a little tricky. Okay, improper integrals. So those are going to involve infinity in some form or another, either infinite discontinuity inside or on the edge, or integrating to infinity. First thing you want to do is check for infinite discontinuities. In this case, it's okay. We're not worrying about it. So the way we write this is write the limit as b goes to infinity of 1 to b. I'm going to rewrite this as x to negative 2. And so we change this into a limit and we just do a regular old integration. Now, as b goes to infinity, that goes to 0, and your answer is 1. So we say that it converges to 1. So that's how we do it. Okay, next one. Probably need to factor this real quick just to see where the vertical asymptotes are. +2, +3. So x cannot be -2 or -3. So that's okay. That's not an issue here. But in order to integrate this, we're going to have to use partial fractions anyways. So that's going to be a over x plus 2 plus b over x plus 3 dx. Multiply 3 by the least common denominator. Plug -2 in. A equals 1. Plug -3 in. B equals -1. So I'm going to rewrite this limit as b goes to infinity of, it's going to be dx over x plus 2, or we could just say 1. We could keep these together if you want, or break them up. But then you're going to have two separate limits also. So the antiderivative here is natural log the absolute value of x plus 2 minus natural log the absolute value of x plus 3, 1b. I want to combine these together to a single natural log. It's probably going to make whatever we do easier using log rules. So if we plug b in, it's b plus 2 over b plus 3. This is absolute value, should still be there. Minus natural log of the absolute value of 3 over 4. Now, as b goes to infinity, you're going to get infinity over infinity in here, which is the indeterminate form. Technically, you would have to use L'Hopital's rule. And L'Hopital's rule would say, okay, well, let's take the derivative of the top and the bottom, and you get natural log of 1, which is 0. So that is going to go to 0. There's the work to support it. So we just have this left over. Negative natural log of 3/4 or natural log of 4/3 if you want to bring the negative in. So there you go. All right, next one. Well, we don't know the antiderivative of natural log of x, so we got to get a little creative here and think of it as integration by parts. And anything could just have one front, which you can consider a polynomial. So you have a poly and a log. So the log's going to be u, poly's going to be v prime. So u equals natural log of x. U prime equals 1 dx. U prime equals 1 over x dx. V equals x. uv, x natural log of x, minus 1 over x dx, x. That's going to be 1. It's going to be x natural log of x minus x plus c. Now, we're not done. This is a definite integral. So we're going to plug limits in. Now, technically, x cannot be 0. So we do have, this is an improper integral. So we really should say the limit as b approaches 0 from the right side. And so this would be the limit as b approaches 0 from the right side of 1 natural log of 1 minus b natural log of b. This is going to be 0. This is going to be 0 times negative infinity, which is indeterminate form. But we can't use L'Hopital's rule yet, so we have to change it to natural log of b over 1 over b. So now it's going to go to negative infinity over positive infinity. So now we can do L'Hopital's rule. And take derivative at the top, take derivative at the bottom. Simplify it. It's going to be negative b. So it does go to 0. And let's see, am I missing something here? Oh, shoot. When you plug 1 in, you get 1 natural log of 1 minus 1. And then minus this minus b. So that term goes to 0. This ends up going to 0 after we prove it. So there is a negative 1 left over. There's a negative 1 left over. So I'm a little crazy. Okay, 22. Can't integrate this. Probably want to rewrite it as x e to the negative x and do integration by parts. So you have poly expo, even if it has a negative. Poly expo. So we could use a shortcut. So it's going to be 1, 0, negative e to the negative x, e to the negative x, positive, negative, positive, multiplied by diagonal. So we're going to get negative x e to the negative x minus e to the negative x it's going to infinity, so we should probably write as a limit as b goes to infinity. Probably should do that earlier, but I'm going to rewrite this as negative x over e to the x minus 1 over e to the x. This is going to be negative b over e to the b minus 1 over e to the b minus plug 0, and it's going to be negative 0 over e to the 0 minus 1 over e to the 0. That's going to be 0. This is going to be 1, positive 1. As b goes to infinity, this is going to go to 0 for sure. This isn't going to infinity over infinity, but this is a dominant term, so that's going to go to 0. So what's going to be left is a positive 1. That's it, positive 1. Okay, 23. X cannot be 2. So that's a problem for us. So we got to break it up. Limit as b goes to, so we're going to go b to 4. So 2 from the, or we could say 0 to 2 first. That might make more sense. So 2 from the left side. And 2 from the right side, we're going to go to b to 4. So it matters which side you're on. So if you're going from the right side of 2 to 4, well, it's got to be superscript plus. 0 to 2, you're going to end at the left side of 2, so it's superscript negative. So it's going to be limit as b goes to 2 superscript negative. Antiderivative natural log of x minus 2, absolute value. This is supposed to be b 0 to b. It's the same antiderivative for both of them. So natural log of b minus 2 minus natural log of absolute value negative 2 plus natural log of 2 minus natural log of b minus 2. So as b gets really close to 2 on the left, That's like 1.999. That means we're going to like a negative, 0, negative, but we're going to take the absolute value. This is going to go to negative infinity. This is just natural log of 2. This is just natural log of 2. Those guys are going to actually cancel each other out. This is going to go 2 plus. It's going to be like positive 0. And it's going to go to negative infinity. But there's already a negative. So it's going to be plus infinity. So what we have right now is negative infinity plus infinity, which is not necessarily 0. You got to use L'Hopital's rule. You got to combine these together. Natural log, I'd use log rules. B minus 2 over B minus 2. And so we're going now to 0 over 0. So we can take the derivative of what's inside. It's going to be 1 over 1. So it's going to be natural log 1, which is 0. So the final answer is 0. Okay, next one. X cannot be negative 2, which is an issue for us. So we got to break it up. So we got to say limit as b approaches negative 2. We're going to go negative 3 to negative 2. So it's from the left side. And then as b approaches negative 2 from the right side. So got to find the antiderivatives. That's going to be x plus 2 to the 1/3 divided by the new exponent. It's going to be the same antiderivative for the other one. Okay, so lots of little details here. So 3b plus 2 to the 1/3 minus 3. Plug negative 3 needs to be negative 1 to the 1/3. Plug 0 in. Okay. As b approaches negative 2, this is going to approach 0. And this is going to approach 0. No indeterminate forms. This is going to be positive 3 plus this is going to be 3 cube root of 2. That's it. It worked. Well, nice. Okay. And good old trig substitution. We can't integrate this any other way. So trig substitution said, all right, let's force trig into it. So sine squared plus cosine squared equals 1 is the main Pythagorean trig identity. If we divide everything by cosine, we get tangent. And I think we could probably use these. And then here we could do cosine squared equals 1 minus sine squared. And we could do tangent equals secant squared minus 1. So we're probably going for one of these patterns here. And there's a couple others that you could use instead of these, but so x is going to equal 5, and we're trying to get something squared minus 1. This is where the 1's going to go. So that's this one right here. So we're going to do 5 secant theta. And so then dx equals 5 secant tan d theta. So this is going to be, let's see, the top, we're going to plug that in. We're going to get 25 secant squared theta minus 25. X is 5 secant theta. dx is that whole thing, 5 secant theta, tan theta, d theta. So the 5's cancel, secant thetas cancel. This is going to be, we're going to pull the square root of 25 out, and it's going to be secant squared theta minus 1, which is going to be tangent squared theta, which is going to give you tangent theta. So we're going to have 5 tangent theta from all that. And we have a tangent theta here. So it's going to be 5 tangent squared theta d theta. Now, to integrate tangent squared theta, we're not going to use double angle. That's for sine squared and cosine squared. I don't think U-Substitution is going to work. What we could do is we could actually use that identity right there to break it up into secant squared theta minus 1, because we can integrate secant squared theta. The antiderivative secant squared theta is tangent theta, right? We do need to get it back into terms of x. So that's where we use the original, U-Substitution definition that we used. I would say, okay, well, that's the same as cosine equals 5 over x, which is adjacent over hypotenuse. Draw a little triangle, theta, adjacent's 5, hypotenuse is x. This is going to be x squared minus 25. So tangent is opposite over adjacent. And theta is going to be inverse cosine of 5 over x, or inverse sine. It should be a 5, opposite of adjacent. So 5's cancel, so we get square root of x squared minus 25 minus 5 cosine inverse of 5x plus c. There are other versions. Here we could have had inverse secant of x over 5 instead. That works. So there you go. 26, I think regular U-Substitution is going to work. So we're trying to get a 1 minus something squared. So I think we're going to go for this one. So I'm going to say x equals 4 sine theta, dx equals 4 cosine theta d theta. Or you could do x equals 4 cosine theta, start that way. So when we write this, it's going to be dx is 4 cosine theta d theta on the top. And this is going to be 16 sine squared theta square root 16 minus 16 sine squared theta. So this is going to be square root of 16 is going to come out. And then that's going to be cosine squared. And so that's going to be cosine theta. So all that's going to become 4 cosine theta. So we can reduce this cosine theta and the 4's. And so what we still have is we have, now I'm going to change this. I'm going to move the 160 in front. And 1 over sine squared is cosecant squared, right? And the antiderivative of cosecant squared is cotangent with an extra negative. And so, actually just cotangent. So now we just got to figure out how to rewrite it back in terms of the original variable. So I'm going to go back up here and say, okay, well, sine theta equals x over 4, which is opposite over hypotenuse. And so I could draw a picture, and opposite's x, hypotenuse is 4, so this is going to be 16 minus x squared. Cotangent, tangent sine over cosine, or opposite over adjacent. Tangent's opposite over adjacent, so this is going to be adjacent over opposite. So the final answer is negative square root of 16 minus x squared over 16x plus c. I think on these we also kind of worried about domain, like this original problem. x cannot be 0. 16 minus x squared has to be greater than 0. So you get 4 minus x, 4 plus x. Do a quick little line check. X equals 4, x equals negative 4. Test the value. X equals 5. Which is going to make it false, true, false. So I think the domain would have to be negative 4 to 0, 0 to 4. All right. So that's all those. Now I'm gonna make a separate video for the related rates problems.